Hi Year 11 Mathematics Advanced students. Today we're doing the second exercise in the topic of functions, which is function notation. Since the value of y depends on the value of x, we say that y is a function of x, and we write this using the function notation as y equals f of x. So the y equals f of x is our function notation. So again, since the value of y depends on the value of x, we say that y is a function of x. So y equals a function of x, where our f stands for function in this case. So we're going to just look straight into examples, and we want to find the value of y when x equals 3 in the equation of y equals 2x minus 1. Basically, it's asking us to sub in x equals 3 into our equation. So when we do this, we have y, when we want to find y, right? So we have y equals 2 times our x value, which is 3, minus 1. So when we work this out, we have y equals 2 times 3, which is 6, minus 1. So we get y equals 5. Pretty simple, right? And this is something that you guys have done all the way through high school. Our second example is to evaluate f3, given that f of x equals 2x minus 1. So we have f of 3, I'm going to sub that in our equation, equals 2 times our 3 that we're substituting in, minus 1. So this equals, so our f of 3 equals 2 times 3, which is 6, minus 1. So f of 3 equals 5. So both of our above examples are the same. They look different because the second one uses function notation. So the second one uses function notation. Now let's look at some other examples where we're using function notation. So we have, if fx equals x squared plus 3x plus 1, find f of minus 2. So we have f of minus 2, that's the number we're going to sub in for x, right? Equals our minus 2 all squared plus 3 times our minus 2 plus our 1. So when we go, we can put this straight into our calculator, or we can try working out. For the sake of this, I'm going to show you the working out. So minus 2 squared is 4, plus 3 times minus 2 is negative 6, plus 1. So 4 minus 6 plus 1 equals negative 1. And that is our answer. You can skip this line of working out by putting it straight into your calculator as well. Example 4, we have if f of x equals x cubed minus x squared, find the value of f minus 1. So this just means that we're subbing in minus 1 wherever we have our x's. So we'd go f of negative 1 equals negative 1 cubed, oops, that's meant to be pink, minus negative 1 squared. So a little tip if we're doing this straight on the calculator is on your calculator, type in negative 1 and hit equals. Now you have this stored on your Casio calculator as the answer. So if you were doing this on your calculator, you go negative 1 equals as our first step, and then you will go answer to the power of 3 minus answer squared. So you hit your answer button, cubed minus answer squared. And this will give you an answer. When you do this, this gives you an answer of negative 2. So that's how you do it on the calculator. Let's just have a look at how we do it manually to see if doing it this way on our calculator works as well. So when we sub our negative 1 in, we know that negative 1 cubed stays as negative 1, minus negative 1 squared is positive 1. So you have minus 1, negative 1 minus 1, which equals negative 2. And look at that, our answers marry up. So this is a little trick when you have fractions or you have negatives and you have to square them or cube them, because on the Casio calculator, when you do this, it does not, unless you put your negative number in brackets, the power does not work properly. Moving on, we have our last example for the moment, which says find the values of x for which fx equals 0, given that fx equals x squared plus 3x minus 10. So what we're going to do is we're going to write out our function. So fx equals x squared plus 3x minus 10, but we're going to make this function equal 0. So when we make this function equal 0, we pretty much take this away, and now we have an equation of x squared plus 3x minus 10. Now we need to use what we did in our chapter 2 of equations and inequalities and solve this equation. So I'm going to solve this equation using the sum and product rule. So I'm going to say that my product is going to be 1 times minus 10, so that's minus 10. My sum is 3, and so my factors of 10, that will get me 3. So my factors of 10 are 1 and 10, 2 and 5. So 2 and 5 are going to get me positive 3, and I will have to make my 2 negative. So in my brackets, I'll have x plus 5, x minus 2 equals 0. So therefore, my x will equal negative 5 and positive 2. So we have found the values of x for which fx, our function, equals 0, given that we have been given our function. We are now going to look at a piecewise function, which is a function made up of 2 or more functions defined on different intervals. So we're going to find the value of f equals 3, f equals 2, f equals 0, f equals minus 4, if our fx equals 3x plus 4 when x is greater than or equal to 2, and minus 2x when x is less than 2. So for our first one, we have f3. And so we're going to use our first one. We're going to use this one here. Whoops. Sorry guys, little technical issues here. We're going to use this one here because f3 is greater than or equal to 2. So we're going to go 3 times our 3 plus 4, since 3 is greater than or equal to 2. So that means 3 times 3 is 12 plus, 3 times 3 is 9, sorry, plus 4 is 13. Next value, we have f of 2, the function of 2. So because 2 is greater than or equal to 0, so since 2 is greater than or equal to 2, we are going to use this first one again in this case. So we go 3 times our 2 plus 4 equals 3 times 2 is 6 plus 4 is 10. For f is 0, we know that it's 0 is less than 2. So because 0 is less than 2, what we're going to do is we're going to use this one here, and so we're going to sub 0 into this one, into our minus 2x when x is less than 2. So it's going to be minus 2 times our 0, since 0 is less than 2, so that will equal 0. And then we have f of minus 4, which equals negative 4 is less than 2. So because negative 4 is less than 2, we use the second function defined. So it will be minus 2 times our minus 4 equals something, since minus 4 is less than 2. So minus 2 times minus 4 is just positive 8. So we have found the value of f equals 3, f2, f0, and f minus 4. Moving on to example 7, we have g of x equals x squared when x is greater than 2. So that's our first bit of information. So x squared when x is greater than 2. We then have that it equals 2x minus 1 when minus 1 less than x is less than or equal to 2. And then we also have, we'll use this green color, 5 when x is less than 1. And what we want to find here is g of 1 plus g of negative 2 minus g of 3. So what we're going to do is we're going to find these out individually, and then we're going to, whatever our answers are, solve them as an equation. So we have g of 1 first. So g of 1 is in between, 1 is in between minus 1 is less than or equal to x is less than or equal to 2. So we are going to use this one here, our pink one, which equals 2 times our 1 minus 1. Since minus 1 is less than or equal to our 1, which is less than or equal to 2. So this will just equal 2 times 1 minus 1, which is 1. Then we have g of minus 2 is our next thing in our equation. So minus 2 is less than minus 1. So because minus 2 is less than minus 1, we're using our green one. So we have it equal to 5. This is since our minus 2 is less than minus 1. And then our final one is g of 3. So that will be our yellow one, because 3 is greater than 2. So since our 3 is greater than 2. So it will be our 3 squared, and 3 squared is 9. So therefore, g of 1 plus g of minus 2 minus g of 3 equals our 1 plus our 5 minus our 9. So 1 plus 5 minus 9 equals negative 3. So we can also substitute polynomials instead of numbers into our functions. So we want to find the function h plus f of h plus 1, given that our function f of x equals 5x plus 4. So what we do here is we have our function h of h plus 1, and wherever we have an x, we're going to put a h plus 1. So this is going to turn into 5 times bracket our h plus 1 plus 4. So then we're going to expand our bracket. So we're going to multiply our 5 by both things in the bracket. So it will be 5h plus 5 plus 4. So 5h plus 5 plus 4 equals 5h plus 9 when we collect like terms. If you are following the Maths in Focus textbook by Margaret Groves, if you are in advanced, you will be doing exercise 302, sorry. 301 was yesterday. So 302. And if you're in or using the extension 1 textbook,